See here. So let's read through our LSTM, you guys. Let's make this happen. Before we're getting to the example, note a few things. Pytorch long short-term memory expects all of its inputs to be 3D tensors. What? Oh, really? 3D tensor, really? Well, you got batch. Is that batch? And what are the other? Oh, one hots for the tokens. Is that what that's going to be? The semantics of the axis of these tensors is important. Okay. The first axis is the sequence itself. So let's see. And the third index, the element of the input. The third index is the elements. All right. I don't fully follow that. We're gonna keep on going. We haven't discussed mini batching. Yet no, we haven't. I don't even. In addition, could you go through the sequence? You could go through the sequence one at a time, in which case the first axis will have size 1 also. Let's see a quick example. Let's type out some code, you guys. Let's type out some code. Just close that. Vim. We'll say example lstm.py. All right. Import torch. We're going to import some other things. Torch.nn.functional as f, I think. I'm pretty sure, right? All right. Import torch.nn. Do we really need to do as nn? Okay. Just to make things a little simpler there. And then we'll also get optimizer. Import torch.optim as optim. Torch.manual. See? We're going to set it to 1 so that way it's always going to work the same way every time. So as we go through the tutorial, we're going to get identical output. Really? There's going to be an output on that? No. Really? Hold on. Let's find out on that. Python example. See, no output. What if we print this though? Print. Is that going to print us something? Are we going to see something? We do. We see a generator. I don't know why. I don't know why this gives you a generator. That doesn't make any sense to me. Is the number of sequences, okay? Time steps or the length of the sequence. Third is maybe number of features are hidden. Okay. Number of features are hidden. Let's see. Third index is the elements of the input. We'll figure this out. We will. We'll figure this out. We're going to remember it too. All right, let's make an LSTM. Okay. Okay, LSTM equals nn.lstm, right? Something like that. And then we give it some parameters. And I forgot what they were. They were like 3, something like that. Probably. Yeah, 3. Okay. Input dimensions is 3. Output dimension is 3. And there's something hidden in the middle. There's something in the middle. We don't know what it is. Inputs. Okay, this is what I was looking for. All right, so this is what we're going to understand here. So we're going to create ourselves. But this is weird. This is odd because this is going to give us an array of tensors, which we don't like, right? We want a tensor of tensors. Or we just want just a tensor. So this is odd. To me, this is very odd. Initialize the hidden state. Why isn't it a tuple? We're doing some very weird non-Pytorchy things right now. Like, we're doing some weird things here. We're gonna figure. So we're going to create some weird inputs here. This is going to be 4 underscore. Really? That's so weird. For nothing in range. Okay. So this is going to be a 5 and 1 and 3. All right. Inputs equals torch.rand 1,3 and 4 underscore in range 5. All right. Let's print this out. Print inputs. There we go. Let's see what that looks like. This is very unusual because you usually want everything on the input side to be a tensor. However, it's an array, which is odd. And so I'm confused by this. We're exiting the loop on Pytorch. All right, let's make a hidden state. 1113. Okay, 113. Torch rand end. Okay, torch rand end. Torch rand. Hold on. I need to see this. Python import torch.rand in 113. It's doing the same thing as rand. What's the difference between rand in and rand? Rand in might give you negative. So hidden equals a tuple of torch.randin 1, 1, 3 and another torch.randin 1, 1, 3. There we go. 4 inputs. So we've got, oh, okay, so for input for n, initialize the state, okay. Step through the sequence of elements one at a time. After each step, hidden contains the hidden state. I don't know about that. I don't know about that. We're gonna find out though. Oh, okay, so let's see what this view is. Oh, so we got a hidden state. Oh, is that where, that doesn't make any sense though. That's not fair. The LSTM, the hidden state is gonna get mutated, right? Is that what's going on here? So once it is getting mutated, so we're reassigning it. Oh, this is what we had the problem with yesterday. Remember right here? All right, LSTM I view 1, 1, -1. Okay, so let's go out equals, out comma, hidden, equals, LSTM. And we're gonna say our I.view, right? We're gonna say 1, 1, -1, which I need to print out to see what that's gonna do. I need to see what this is. All right, view equals. We're gonna do this. I need to see it. I need to see it. I can't not have it. View comma hidden. There you go. And we need to print. I want to print the view. We're gonna use an F print here. F print. View equals, like that, just like that, you guys. We're gonna get the output and the hidden. We need to see it. We need to see all of it. And a loot box. Hey, how's it going there? Boo Jam, welcome on in. Roblox also, yep, got some Roblox in there. I need to see what this is. Let's print it out. Let's print it out. Oh, we got a whoopsie. Where's our whoopsie at? I'll figure this out. Line 11, right here. Oh, because it wants to be a tuple, which is very weird. I don't know why. The green orbs. The green orbs are my favorite. I like the green orbs. They do a really good job. They've got my favorite song in this playlist, which is going to come up here in a second. It's Temu Claude. Yes, it's discount Claude. I like that. All right, you guys, this is very weird for me because the view is the same as not being a view. Because I know the view will transform the data shape, and we set it to be 1, 3, and it's still 1, 3. So why? The output tensor is another 3-dimensional array. Oh, wait, no, I see the difference now. I see the difference, you guys. It's off by 1. It's adding a dimension, is what it's doing. It's increasing the dimensionality. So I get it. Okay, that's fine. It's just adding a dimension. It's adding a dimension. So it's 3D. It is now 3 dimensions, which the LSTM wants. Remember? It wants a 3D tensor. LSTM likes 3D tensors. Yes, got it. Yep. That's what we learned. That's what we just learned right now. So we needed this layer right here. We need that transform to give the LSTM what it's really looking for. It wants 3-dimensional tensors. And our hidden state changes. So I want to take a look at just the hidden state now. Let's take a look at that. I want to see as it changes. Okay. So here's our hidden state. We've got a -1. It goes, it drops. So see how it's maintaining its memory. So we got it's very weird though that the hidden state is looking for a tuple of tensors. It's just odd. It's fine. It's just that I'm usually used to having Pytorch maintain its own structure. Yep, because it's short-term memory, it'll easily be forgotten. So I'm pretty sure that's what that is. Okay, so did we type all of it out? Okay, we typed out this part here. Okay, let's read through our code comments here. Yeah, Alternatively, we can do the entire sequence all at once. Isn't that what we just did? Oh! Instead of doing them in a loop like this, we can do all of them at once. Okay, they were just doing this on purpose to show what each of the hidden state changes are. I think that's why they did that. Okay, because it's easy to view how the hidden state changes, the short-term memory, right? So, compare with the last slice of the ad. Yep, they are actually the same. The reason for this is that the out will give you the access to all the hidden states in the sequence. Hidden will allow you to continue the sequence and back propagate by passing it as an argument to the LSTM as in later time. Now hidden state. Okay. So let's clear this up. So this part right here is optional. They're just showing us for reference what that was. So we can delete that for loop now. We don't need this anymore. I'm going to comment it out though. That's what I'm going to do. There we go. Commented. And we will leave that for it is. So we got our hidden state. We got our inputs too. Do we still have our inputs over here? Do we need to redo that? Oh, our inputs are going to change. We're going to change up our inputs, you guys. All right. So we got our hidden state. We're done with that. Now let's run through our LSTM again. So let's do this. Okay. So we got our hidden state, which I think is the short-term memory. So we got our short-term memory. We got our LSTM here. We got our inputs. Now let's delete that and do out, comma, hidden equals LSTM. And we're going to do the view again. Yeah, or no, we don't need to because we already changed, we transformed it here, which isn't the same kind of view as this. This is a different view. It's different. Probably because we were running it through one at a time, so it didn't need to be. I guess, I don't know. So it already is a 3D. Oh, okay. Let's print. Did we do this? Oh, did we run it yet? Did we run it? Here we go. Let's run it. Okay, here we go, you guys. So now we've batched it out. So it's a 3D input, and we get a 3D output as well. A very big 3D output. Not that big. And then we get our hidden state as well, which we know about. We know about that. And it's always going to be the last output and some other number here, which is some other short-term memory, I'm guessing. What are we making? How's it going there, Kibber? Oh, good to see you. We're building a long short-term memory model. We're learning it. We're going through the tutorial. We're reading all the docs, and we're reading through it. Yep, so that's the output we got. Okay. So it likes 3D inputs. That's as far as we understand that. Which this already is a 3D input. This already is 3D. It is. And so I don't understand why we need to do the view. Oh, whoop. Let's go back there. So this view right here doesn't make sense to me. I'm assuming that we can try this out. Let's try this out. Does that make it a tensor? Oh, it makes it... Okay, hold on a second. Let's see. Print input. We'll do that again here. Let's find out. Let's find out. I really need to see if this... Because it's got to do something, right? It's got to do something. Oh, it does do something. Okay. So here's what it does. It keeps the numbers the same, and it converts them into a 3D tensor. So you can see there's 3 brackets here versus just 2 brackets, an array of tensors. So that's what's going on. It is converting it into a matrix or a cube, right? It's converting it into a cube. So that's what we're seeing here. It's a cube. We're getting all the edges. Okay, so this is doing something. It is doing 100%. That's amazing. Okay, let's continue on with our tutorial here, you guys. Let's keep going. In this section, we'll use an LSTM to get part of speech tags. We will not use This is where we got sidetracked on VERB. VERB could be used after you've seen what is going on. Okay. In this example, we also refer to embeddings. If you're unfamiliar with embeddings, you can read up about it here. Let's do a quick little scanning on embeddings. Word embeddings, encoding lexical semantics. Word embeddings are dense vectors of real numbers, one per word. Oh, a vector of real numbers. Okay, so 1 vector per word. 1 vector per word. That's a lot of data in your vocabulary. In NLP, it's almost always the case that your features are words. That's right. That's what the features are. That's the input. How should you represent a word in a computer? You need to give it numbers. You could store it as an ASCII character representation that only tells you what the word is. It doesn't tell you much about the context or what the word means. You might be able to derive its part of speech from its affixes or its properties from its capitalization. Not much else though. Even more, in what sense could you combine these representations? Right? We know. Let's prepare our data, you guys. Let's prepare our data. Okay. Okay. Prepare sequence. Sequence 2ix. What is 2ix? It's our dictionary. 2ix? It's our dictionary, right? This is our dictionary of words. It's cardinality, right? Word cardinality. Our what is that? What is that library system that indexes books by ID, right? It's an indexing system. Target space, you guys. How's it going there? It's a little toilet. Good to see you here. Welcome on in. Good to have you here. All right. Training data. The dog ate the apple. Hey, we said what our favorite fruit is. What's this? What's this right here? What are these? Hey, tutorial. Tags? Oh, they're tags. For the word? Tags are determine, noun, and verb. Determine, noun, verb, determine, in. Huh. Okay. Now, Little Toilet is going to feel bad. Oh, really? Oh, no, Sam. I was about to call that out. Mod who deleted that rude comment. Oh, yeah, Bonzoopy, thank you. Thank you, Torva. No, just banned. All right, straight up ban. You get the heavy hammer. Got the heavy hammer on that one. You get the heavy hammer. Straight banned. All right, everybody read that book. It's gonna be book V. All right, so these are the tags. So we're gonna have 2 indexing systems. Let's read through this. See, I told you. Right there. It's the dictionary. See the dictionary. You guys. Let's create our prepare sequence. I don't like how they're doing this though. I want to do it differently. Sequence to ix. So we got our 2ix in here for the sequence, which is fine. So let's do a dictionary. So let's get our training data first. Let's create our training data. We're gonna create our own training data here. Okay. Vi ls full LSTM.py. Full, please. Python. Full LSTM, please. Oh, we didn't save it. There we go. Okay. Import torch. Import torch.nn as nn. We import torch.nn.functional as f. Import torch.optim as optim. Bro's locking in. You know we're locking in now. Whoop. Oh, close that out. All right, let's open that again. All right, so we need to do our training data. Training data equals. Now, we're gonna do something different. We're gonna change it up here. We're gonna do it the way we want to do it. We're gonna follow the tutorial. We're gonna make some changes though. We're gonna make some changes. All right, so let's go here. The dog ate the apple. We should probably do lowercase, and we should probably do a few other things. And then we're gonna have our so this training data, so features and labels. Our features and labels, which we'll extract this later. We'll extract it later. So we'll say determiner is a noun. Determiner. About which algorithms to apply under which circumstances, which is mostly what we're trying to learn here on this stream right now, as we're building an LSTM. Vectorizing data, encoding, decoding. A good portion of a strong AI engineer is knowing how to deal with data, because about more than 50% of AI is preparing your data. So we got our dictionary, and we got our words are here. So we got our training data. Let's build our dictionary. Def build this dictionary, and then we're gonna have our training data. How about we just say data? Okay. So for hold on. So they want it to be a tuple. Okay, X tuple. Because we need this is like together. These are pairs. They're pairs, so they have to be together. Okay. So we're gonna go for let's go D in data. We're going to create this sentence equals D 0, and then we're gonna say for W in, this will be the sentence. I always misspell that. Dot split on the space, and then we want to lowercase this. How do we do? To lower. Can we do that? Is that how we do that in Python? Dot to lower. No, that's not it. Maybe it's just lower. Okay, it's just lower. Okay. Okay. Then we're gonna get our dictionary. We're gonna create a new dictionary. All right. So this is gonna be our updater. We're gonna say, how do we want to do this? How do we do this, you guys? Because we're gonna have multiple sentences now, so we have to do it a little bit differently. I don't know why, but loving reading data stats, handling data with the code it's very painful. You're right, it is. We're doing that right now. We're going through the pain. I missed the joke. I didn't get it. Sorry about that. I'll try better. All right, offset. Dictionary. I need to see the dictionary length equals 2. Okay. All right. Len. Can we do that? I think it's gotta have a len. Yeah, it does have a len. All right. Len. Dictionary. So here's our offset, and then we're going to create our update. Update equals. We're gonna do that here. Offset plus. Let's see. For word, comma. Yeah, that is word. I need to enumerate this though. Like that. There we go. This will be word, colon, offset plus index. There we go. Index. Hey, look at that. Look at that, you guys. There we go. All right. Here's the update. I think that's it. I think we're good there. Okay. Good right there. Update. Done. Done. I think that's it. I think we did it. We'll do sample.